Okay, so everything you need to run the Shoreline Digitization script tool is here at github.com/2.34/Shoreline Digitization Arc Pro. Several folders here. One, this contains the actual code, the Python .py script. This is sample data to make it easier for the user to test out the script tool. This is some instructional information, and this is the tool itself. To get all of these files on your own computer, all you need to do is go to the green code button and select Download Zip. Okay, downloading zip archive. It's about 63 megabytes, so it shouldn't take too long. I've gone to where that downloaded, and it's a zipped file, so I'm going to unzip it. And there we have it. Now on our local computer, all those same files that were on GitHub. Now let's take a look at the tool. The tool is also a zipped file, so extract that. And we open up the file, and there are hypothetically two ways to access the Shoreline tool now. One, this is an ArcGIS project file right here, and I could open that up and hypothetically run the tool that way, but I actually run into some issues there, and I think it might have something to do with the zipping process and the uploading of this project file to GitHub. So what I would recommend actually is just accessing the ArcGIS toolbox from a project you already have open in ArcGIS Pro. So let's see. I'm going to create a new one here, Shoreline Digitization Demo. Just a blank project, nothing in it whatsoever. But you can see here on the Insert tab, there's an option to insert a toolbox, so Add Toolbox. And we can navigate to the location of, let's see, not sure if that's the right place or not. Let's go to make sure, okay, tool. Here it is now, it's a toolbox. And we add it. Okay, nothing's gonna happen very obviously, but we go to View and Catalog pane, and under our toolboxes, we'll see that we actually have added our toolbox. Now, let's take a look. Right-click on that on the script, which is within the toolbox, and then select Properties. The parameters are all in here, so I would recommend against changing any of these parameters unless you have some experience with the script tool and want to customize it in your own way. General is just some names, and execution, this is important. This is where we connect the script itself, the .py file, so that it can be run in the script tool. Looks like I've already done that, but there it is right there. That would be within the code folder, .py file. Okay, now the script tool is already set up, and you would use it just like any other ArcGIS tool. So we'll double click it. Our first little trial run, we're going to just use imagery. We're not going to use a DEM. So image raster folder. Let's see. Go back again to the folders we downloaded from GitHub, and this is our sample data here. So let's use Sanford Lake 4-band. Double click, there's nothing in there because what the input actually wants is the folder. So that's the folder. Click OK. The Sanford Lake imagery is NAIP, National Agricultural Imagery Program, and I know from that documentation that blue band is 3, green band's 2, red band's 1, and the near infrared band is 4. Now, if this were Landsat data, blue band would be 1, then 2, then 3, then 4. And you might have, in Landsat, you would have a shortwave infrared band. In NAIP data, you do not, so we leave that blank. Demo, just add anything there that's a that describes the particular run of this tool. Output geodatabase up here. Usually the top entry in that list is actually our default geodatabase. So click on that. Again, no DEM on this run. Manual threshold. And try this. And the instructional document explains more about that. But I'll just put those numbers in there and we will run the tool. So the tool has finished running and it ran successfully, as you can tell by this green check mark here. Just go ahead and close that and look at the output. I guess first let's look at the details. Took a touch over 10 minutes. Close these and we'll look at the output. Control and uncheck all those, and we'll just take a look at the polygon output first. Up the attribute table. Okay. This merge SRC field is where you'll see the name of the outputs over here. This is the algorithm used to derive that output. I've also added an algorithm for unsupervised classification based on ISO clusters, but I haven't quite made that version of the code stable yet, so it's not actually in this demo. But let's take a look here. You can see the outline of the lake created by that algorithm, the Otsu NDWI, and by the next algorithm, and these by our custom thresholds for NDWI that we added. Now, the main benefit of leaving the polygon input in is we've got this shape area here, so we can very quickly and easily estimate the area, and if we had a DEM, say, of that area with some bathymetry of the bottom of the lake, we'd be able to remotely estimate also the volume of the lake or water body. Let's take a look at the line output. It corresponds to those polygons. Same deal. I don't actually have the images here right now, but we can add those straight from the sample data folder here. Let's see. So sample Lake 4 band. And this will allow us to visually compare the shoreline, digitized shoreline from the tool with the just manually unchecking these so that we only have 18. You see how good of a job our tool did. Now I chose this Sanford Lake for several reasons. One, it's actually was the site of a dam break a couple years back, and so there's been a lot of change in water levels. So it's an interesting place to study, but also because the shoreline's actually pretty complicated. You can see all sorts of docks and trees and tree shadows, and you see that the tool has actually still done a fairly good job. Different algorithms might include or exclude the shoreline features. And you see number 2, that one did a really good job of excluding this area here, whereas the others didn't. And I've run the unsupervised classification even though it's not included in this output. This number 2 did better than the unsupervised classification based on ISO clusters. That's standard with ArcGIS. All right, so this is the output for the simple shoreline digitization of multiband imagery. The script tool also has the option of comparing this digitized shoreline to a contour drawn on a digital elevation model. And you can use real water level or tide data values so that you can draw a contour line on the DEM at the level that the water was measured at the time that the photo was taken. It's kind of a mouthful there, but should become clear as I show you the next demo here, which is I'm going to use point Reyes data. This is the multiband imagery. I guess I need to go back up one. Again, we're looking for a folder input, so there it is. Now our DEM imagery or DEM raster here, digital elevation model. Put that in. This is Landsat data. Now, I would say Landsat data is a little bit too low resolution to really make full use of the Shoreline Digitization Tool. It's 30 meters by 30 meter pixels, but just for the sake of, I guess, giving an example, Landsat has a little bit of different band order than NAPE. We have all 5 bands in this sample data. Let's do Landsat demo. I'll put geodatabase the same, just our project default database. Here actually, okay, we've got our image DEM water level spreadsheet. Before running the tool, I'll go over that spreadsheet a little bit. Open that up. For some reason, it makes us select a sheet, but that's not really the format that the tool wants it in, so I delete that sheet and just end with an XLS or XLSX file ending, and we'll do the same threshold we did before. And actually, I'll go ahead and get that running, but then we'll look over, let's see where the data here. Okay, this is a spreadsheet. Okay, so you can create this spreadsheet yourselves, but make sure that it has these exact field titles, because that's how the script tool will know where to grab the data within the spreadsheet. So image base name, it is caps or case sensitive, so capital IBN, DM base name, and water level. I just use 0.5 and 1. Those are just arbitrary, but ideally you would look maybe on the NOAA tide data and find out what the water level above a certain vertical datum is at the time that your image was captured, which also ideally would be at a time similar to when your DEM was created. So I'm going to go ahead and pause the video and let this tool continue running. Okay, so now I'm going to do a little trial run of multiband imagery along with a digital elevation model. You can always find the Shoreline tool in the catalog. Add, like we did before, our multiband imagery. In this case, it's point radius multiband. We add our DEM. This is all just straight the files downloaded from GitHub. This is Landsat data now, so I happen to know the band order. It's in order of wavelength. We do have a shortwave infrared band with Landsat data, with the sample data, so we'll include that, and that will include the modified normalized difference water index. Let's see, so let's do 5 band with a DEM. Geodatabase, just our current project database. I'll get back to, there's our sample data spreadsheet. Open that up. And for some reason it wants us to add the sheet or sheet 1, but that's not actually the format we need it in. We just need with a .xls or .xlsx ending, so I delete that. We'll do a 3 manual threshold input again, run the tool, and I'll pause it and come back when there's an output. So now our tool has finished running, and green check mark means it was successful. Took 6 minutes and 24 seconds. So now we can take a look at the tool's output. Here's a multiband image of the area that we analyzed, Point Reyes, California. First output of the tool is the contour drawn on the digital elevation model. And this one's called the ground reference water level because this comes from presumably an actual physical ground-based measurement of the water level, maybe from NOAA data. Take a look at this. Layer. So we just analyzed a small segment of the image that corresponded to the DEM that we have. And this line here was created based on the spreadsheet that was included in the sample data. And it was drawn for 2020. It was drawn at 1 meter. So the point Reyes imagery is actually Landsat data, so it has a 30 meter pixel size. So there can be a lot of vertical elevation change over 30 meters. So this is actually not the greatest data to show this DEM contour on, but it's, I think, good enough for these purposes, just to show you that it's a product of the Shoreline script tool. Another product, let's look at this here. Is the shoreline features itself. You can see there, it's delineated the shoreline fairly well, and this is based on several algorithms. Look up the attribute table. This merge SRC field shows you which algorithms were used. I did recently update the code, so now it includes the unsupervised ISO cluster-based classification. But suffice to say, you can look at the different algorithms that were used and see which one, at least for the section of coast that you're looking at, did the best job at delineating the shoreline. And that is the goal of this tool, is to completely automate shoreline delineation. And again, this is 30 meter pixels, so not a super high level of accuracy, but a lot of these algorithms did a pretty good job. That one didn't. You can't even see the line there. That one not so great. Looks pretty good. That one not so good. There's the idea of it. So a third product of the script tool is polygons. Take a look at those. Attribute table. They're based on the same algorithms as the shoreline features. In this case, the unsupervised classification, I think, did a really good job. It wasn't the best algorithm from the Sanford Lake data that we looked at initially, but in this case, it's a really good one. We'll make a selection on that. From the selection, we're going to make a layer from the selected features. Now we get to see what this polygon's actually all about. And it represents the water body. And since this is the ocean, it's not particularly useful for determining surface area. But if we were doing an inland lake that was fully captured within the image we're using, we could then use this shape area field to estimate the area of that water body, and that could be very useful for looking at volume changes, water volume changes, and if you had a digital elevation model that included I think it's called bathymetry or topobathy, but the lake bottom, then you could do water volume estimates.